Alright, we have a problem with the D, and on the 4-foot only. Seems like it got a little bit of percussion to it. Key contact, key click. 3.2 volts. Okay, I'm looking for a DC offset on D because we have a key click that's rather loud and it sounds like percussion. So what we're going to do here is we're going to check the dividers for voltage, DC voltage, and this one is 3.25 volts. It is 1, 2, 3, 4, 5th. It is the second to the last divider. 1, 2, 3, 4, 5th pin in, and like for example on the D sharp card, that one reads 0 and that one reads 3.25 volts. So we know we have a bad capacitor because the outputs are AC coupled through the capacitor, and this means the capacitor is shorted. This puts a DC bias on the key contact, which is how you hear the click. In some cases they want DC bias on the key contact, but not in this particular unit. It is in units using diode keying. So we're going to follow this back. 1, 2, 3, 4, 5. That's the second one right here, and that's this capacitor right here. So we're going to take the capacitor and measure it, see if there's any, trying to get the test lead out here, any possibility the capacitor is shorted. And, gee, 1670 ohms. That doesn't look too good. Let's take the capacitor itself and yeah, we're going to undo it. There we go. Now this is let's see now. Hard to even read this one. We'll have to look in the diagram to see if it measures any resistance now. Then yeah, about 2,000 ohms, 1,800 ohms. The capacitor is no good. To find out what value it was, we're going to check our schematics, and the value of the capacitor changes. There's first divider, second divider, and there's one capacitor that's down to ground, and the second one is a coupling capacitor. This one reads 04 according to the print, so we're going to replace it with an 047 at 50 volts, and that should do the trick, and that should get rid of the key click. We're inserting our new capacitor, and it's much smaller than the original. There we go. And we're going to solder it in place. And then we're going to clip the excess leads off. I'm just going to make sure one more thing. Yeah, that's it, 473. Alright, and then once we do that, we're going to put it in place with the rest. And what was that? That was a D.
Voila.
And just shows you what a little capacitor can do if it's left to its own device. And you should always double check for a DC pulse because these organs are AC coupled through a dual capacitor network. And if all of a sudden you start seeing voltage, that's generally a clear sign that voltage from the flip-flop or the divider is coming into the key contacts. That will produce a percussive-like effect that we allow click and pop.